Okay, students, good morning to all of you. So we are discussing about objective, no? Yeah, atoms chapter objective, no? Can you see this on your screen? Questions, can you see? I have shared your screen. See once, if it is visible, tell me now first. Yes, sir. Okay, good. Good. So now we are doing question number 26 now. No? Yes. See, in X-ray tube, electrons accelerated through a potential difference of 15,000 volt and strikes a target. The speed of emitted X-rays from the tube is. What is the speed of emitted X-rays from the tube? Okay. See, they are called as these are X-rays. X-rays are nothing but electromagnetic waves. Do you know all the electromagnetic waves moves with a speed of light, that is 3 into 10 to the power of 8 meter per second. X-rays moves with the speed of light. So no need to think about how they came. Just 3 into 10 to the power of 8 meter per second is the right answer. Are you understanding? And some students, what they will do know, we know kinetic energy Ke is equal to electron volt. So kinetic energy is nothing but half mv square is equal to electron volt. Then V is equal to electron volt into 2 upon mass under root. Means 2 into E into 1500, sorry, 15,000 divided by M root. So where is the option? Option C, option 2 is there. So they will take. Oh, it is wrong because these are X-rays now. These are X-rays. X-rays always moves with the speed of light. Okay, don't get confusion. Option 4 is right answer. Got it? Students, are you understanding? Next question number 26 is over. Let us go to question number 27. Nana. See there what they have given. Question number 27 I am taking. Yes, students, you have on 5th you have physics exam and syllabus for that exam is already you have written chapters, that is ray optics, wave optics, ray optics and dual nature and atoms. These 4 chapters. So that I have completed these 4 chapters objectives also. Some objective and objective nana. See, from this 5 marks question they will ask in your board exam. From this also 5 marks question they will ask in your board exam. So if you perfectly read these 2 chapters, definitely you will get 10 marks. No doubt it is. Minimum 10 marks. Maximum this is 8 marks. This is 8 marks, means maximum 16 marks you can get if you read these 2 perfectly. And however, this chapter 3 marks weightage, this chapter 5 marks weightage. Total, if you read perfectly, you will get around 20 to 25 marks. So that's why I have chosen these 4 chapters. And already all these 4 chapters objectives already finished. That is the reason. Okay, prepare well. Exam will be on these 4 chapters on 5th on Tuesday. Okay, and batches will be divided on this marks of this chapter. This test only, okay. Be serious about your preparation. Next question number 20. Yes, 27. The momentum of photon in X-ray beam of 10 to the power of minus 10 meter wavelength. Means wavelength they have given how much? 10 to the power of minus 10 meters they have given. Okay. What is the momentum of photon? They are asking. You know, momentum of photon P is equal to h by lambda according to de Broglie. We know. X-ray photon. So a photon in X-ray beam, they are asking, okay, that is h by lambda. We know h is equal to 6.63 into 10 to the power of minus 34. Correct? Yes or no? Minus 34 joule second upon lambda given 10 to the power of minus 10 meters. So what you will get? 10 to the power of minus 10 cancel with 10 to the power of minus 24. Yes. You will get 6.63 or 6.6 into 10 to the power of minus 24. Unit what? Kg meter per second. Yes. Option A. Yes. Option 2 is there. Right option. Correct? Yes. Next. Question number 28C. Logical question. It is just logical question. Nothing is there in this. See, the energy of photon of light with wavelength 5000 angstrom is approximately x electron volt. Means when lambda is equal to 5000 angstrom, the energy is equal to how much? X electron volt they are given. Okay. Then this way, energy of X-ray photon with wavelength. When lambda, different wavelength I am taking. Wavelength is lambda equal to 1 angstrom. Then what is the energy they are asking? Clear? Yes. See, simple. We know energy is equal to hc by lambda. That means h is constant, c is constant. Means energy is inversely proportional to wavelength. Correct? Yes. So this is E2 you take. I want E2 by E1. What you will get, Nana? Because inversely proportional, it will become lambda 1 by lambda 2. Correct? Yes. So E2 will become lambda 1 by lambda 2 into E1. Yes. Lambda 1 by lambda 2. Yes. Lambda 1 value what, Nana? 5000 angstrom upon lambda 2 how much day 1 angstrom into E1 how much day x electron volt angstrom cancel what you will get na 5000 x electron volt. Yes, this is the energy. Perfect. Yes, 5000 electron volt into x. Yes, it is third option is right answer. A simple basic question. Only the thing is you need to be perfect with these type of ideologies. Okay, Nana? Clear? Yes. 29. Question number 29. See there? What they have given? Yes, students, 14 members are there. Question number 29. Nana? See. The kinetic energy of electron which is accelerated through a potential difference of 100 volt. You know kinetic energy Ke is equal to electron volt. Yeah, electron into voltage how much? 100 volt. Is equal to how much? 100 electron volt. Clear? Yes. But options 100 electron volt here. Electron volt option is there here. So wrong it is. But here see in joules it is in calories it is. Yes. So we know 1 electron volt is equal to 1.6 into 10 to the power of minus 19 joules. No? Yes. Substitute here you will get 100 into 1.6 into 10 to the power of minus 19 joules. Yes. So it will become 1.6 into 10 to the power of these two zeros cancel with 10 to the power of minus 17. Correct? Yes. 1.6 into 10 to the power of minus 17 joules. Option is there? Yes. Option 1 is there. Clear? Option 1 is right answer. Got it, students? A easy question. You need to have idea on this conversion factor. That's it. Okay. Next question number 30. The wavelength of most energetic X-ray emitted when metal target is bombarded by electrons having kinetic energy 100 kilo electron volt. Okay. Kinetic energy how much given, Nana? 100 kilo electron volt is given. Okay, they are asking what is the wavelength of lambda is equal to 12,400 upon what energy it is in electron volt. Then you will get lambda in angstrom. Do you remember this formula? Yes. So here see 100 kilo electron volt means 100 into kilo means 1000 electron volt. Substitute here it will become you will get lambda in angstrom is equal to 12,400 electron volt upon this energy. How much? 1, 2, 3, 4, 5. Yes, 5 zeros. 1, 2, 3, 4, 5 zeros. Electron volt cancel. 2 zeros cancel. 124 by 1000 is nothing but 0.124 in angstrom. Yes, 0.124. Where it is? 0.14. Yes, option 4. Perfect option. Got it, students? You need to remember this. Wavelength when you want in angstrom, this is the formula. When you want wavelength in nanometer, the formula is 1240 electron volt upon energy. Thing is, here energy should be in electron volt. Then only you can cancel. Sometimes they will give energy in joules. You need to convert into electron volt. Be careful that conversions. Okay? Yeah. So 30th option 4 is right answer. Got it? Yes. Students number is very less. Next 31. Question number 31. See what they are given. For harder X-rays. So X-rays are two types, na? One is soft X-rays and another one is hard X-rays. Hard X-rays. Soft X-rays is nothing but frequency is less. Hard X-rays is nothing but frequency is more. Like this we can differentiate the X-rays. So for harder X-rays, what should we can say? Frequency is more. Yes. Option 4 is right answer. Okay. Softness and hardness of the X-rays cannot be decided by intensity. So wrong. Photon energy also wrong. Wavelength is higher. See here, wavelength is higher. Frequency more means wavelength should be less. But here wavelength is higher they have given. So wrong. If they have given frequency is lower, then it is correct answer. Soft X-rays frequency less means lambda should be more. Careful na? Okay. So option 3 only right answer because they are given harder X-rays. Frequency should be higher or wavelength should be lower. Clear? Yes. 32. Question number 32. When cathode ray strike a metal target of high melting point with high velocity, then what happened? X-rays produce. This is how X-rays will produce. Yes, correct answer it is. Okay? Yeah. Next. Question number 32 or 33 now. Question number 33, see. The penetrating power of X-rays can be increased. How can we increase the penetrating power? So if you increase the energy of X-rays, penetrating power also increases. Penetrating power also increases. Okay, if you increase the energy, penetrating power also increases. So how to increase the energy? Energy is nothing but E into voltage. Okay, yes. If you increase the potential difference, then we can increase the energy. If you increase the energy, we can increase the penetrating power. Are you understanding? That means the penetrating power of X-rays can be increased by increasing the potential difference. That's it. Okay, here see. Increasing the potential difference between anode and cathode is perfect answer. Understood? Option 2, decreasing the potential difference, wrong. Increasing the cathode filament current, wrong. If you increase the filament current, intensity increases. Intensity cannot change the penetrating power. Intensity can change the number of photons striking the surface. That's it. So it is wrong. Decreasing the cathode filament current, it is also wrong. Option 1 is right answer. These are just subjective points. You need to remember all these points. Clear? 34. Question number 34. See, K alpha characteristic X-ray refers to the transition. K alpha is nothing but, see here, nucleus will be there. Around this nuclear, K shell will be there, and here L shell will be there, and then M shell will be there, like this. K alpha means electron is transiting from n is equal to 2 to n is equal to 1. This is K alpha. If electron transition is from n is equal to 3 M shell, okay, 3 to n is equal to 1, then it will be called as K beta. Do you know these all things? In chemistry you have studied. Okay, yeah. So K alpha characteristic X-ray refers to n is equal to 2 to n is equal to 1. Point is important. If you take n is equal to 4, fourth orbit here, see like this. Fourth orbit if you take from here n is equal to 4 to n is equal to 1, then it will be called as K gamma, like that. Clear? If the electron is not coming to K, if it is coming to L, means from n is equal to 3 to n is equal to 2, it came like this, 3 to 2. This will be called as L alpha. 4 to 2, it will be called as L beta, Lyman series, like that. Okay? You need to remember these all points. Next, question number 35. See there what they have given. Question number 35. Yes. The production of X-rays is due to, how this X-rays can be produced. The production of X-rays is due to, first, Transfer of momentum in collision of electron with the target, no, wrong. Okay. Transfer of energy in collision of electron with the target atom, no, wrong. Transition of electron in heavy at target atom from higher energy level to lower energy level, yes. This is how the X-rays will produce. See, here there is an atom is there, Nana, like this, whose atomic number Z is more. Then when a fast moving velocity is more, fast moving electron, when it will come here this is nucleus, first orbit, second orbit, like this. It will interact with the electron in the first orbit. Let us imagine. Here one vacancy will be created. Due to this vacancy will be filled by the electron in the highest orbit energy level. So it will radiate like this. It will jump from here to here like this. Due to this, radiation will produce. That radiation is called as X-ray radiation. Are you understanding? Clear? Okay? Yeah. So the production of X-rays is due to transition of electron in heavy target atom from higher energy level to lower energy level. First option C, transfer of momentum in collision of electron with the target atom. So if this electron is collided with the target atom, momentum will transfer. Due to that, X-rays are not producing. Transfer of energy in collision of electron with target atom. This electron, it will give its energy to this electron. Due to that, X-rays are not producing. Due to that, electron is going into higher energy level, and from there it is coming back. Are you understanding? Clear? So option 3 is right answer. Conceptual question, Anna. Transition of electron in the heavy target atom from higher to lower energy level. This is right answer. Next, important question. See, X-rays are produced in X-ray tube operating at a given accelerating voltage. The wavelength of continuous X-ray has the value. See, continuous X-ray spectrum, if we observe here, wavelength here, intensity, the X-ray spectrum comes out to be like this. It is up to infinity. And here it will start from one minimum wavelength. Okay, na? Minimum wavelength will be here. So it will be some minimum wavelength to infinity, and this minimum wavelength should be greater than 0. Yes, option 2 is right answer. Important question, Anna. Very important point. You need to remember this. So this X-rays production, for X-rays production, wavelength should be having some minimum wavelength. Higher than that minimum wavelength only possible for continuous spectra. Lower than that minimum wavelength is not X-rays. Remember this point. Clear? Yes. Next question number 37. Question number 37, Anna. Yes. See there. Question number 37. The ratio of energy of X-ray photon of wavelength 1 angstrom to visible light of wavelength 5000 angstrom. Okay, X-ray photon, wavelength given on a photon is 1 angstrom. Okay, wavelength of visible light means light rays is 5000 angstrom. Okay, yeah. What they are asking, ratio of energy, you know, energy is equal to hc by lambda, means energy is inversely proportional to wavelength. So what they want, from photon to visible light, photon to visible light ratio they want, energy means inversely proportional. You will get 5000:1. Orally we can give answer. Are you getting? See how energy of photon to energy of visible light can be written as lambda of visible light by lambda of photon, because it is inversely proportional. Lambda of visible light is 5000 given, and photon is 1 angstrom. Angstrom cancel, it is 5000:1. Yes, option 2 is right answer. Clear? Next. 38. According to Moseley's law, what it is saying? Square root of frequency is proportional to Z minus K. This is Moseley's law. Here K is screening constant. Means it can be written as root f is proportional to z minus 1, we can say. K is equal to 1 for k alpha lines. Okay, yes, this is mostly a statement. Now see, frequency of characteristics express line spectrum varies as atomic number of element, wrong. Square of atomic number of element, it is correct. Root f is z minus 1. Then f is proportional to z minus 1 square, no, s. Frequency varies as square of z atomic number. Square root of atomic number, wrong. Square it is. Okay. Fourth power also wrong. Option 2 only right answer. Remember this type of questions, easy questions to score. So 38 is over. Option 2. Next. Let us go for 39th question. Yes. Question number 39. See again conceptual questions. For structural analysis of X-ray analysis of crystal, X-rays used because why X-rays are used? Main reason is X-rays has a wavelength of order of interatomic spacing. This is the reason. See, structural analysis, X-ray, Bragg's equation, Bragg's studies on the structure of the crystal structures. We have studied simple cubic system, FCC, BCC. These all things we have studied. No, yes, there. X-ray analysis we have studied. Here layers will be there. Okay, here atoms will be there. Have you studied in chemistry? Okay. First layer, second layer, third layer. So X-rays, they will fall on this and they will scatter like this. This spacing between these two is D. Okay, and these X-rays, when they incident at an angle theta, yes, we know 2D sin theta. 2D sin theta should be equal to n lambda. Clear? For maximum value of sin theta is 1, means 2D is equal to n lambda. Are you understanding? For first layer, means n is equal to 1 layer, it will be 2D is equal to lambda. Remember this point. Means the wavelength of this rays should be equal to interatomic spacing between these layers. Means these two orders should be same. Order, range should be same. Only the X-rays have that range of in angstrom. X-rays wavelength is in the range of angstroms. So that's why only X-rays we will use for the structure analysis of crystals. Okay, so first option is right. X-rays are highly penetrating radiations. This is a correct, but this is not a reason for the structural analysis of crystal. Wavelength of X-rays is order of nuclear size, wrong. Nuclear size is 10 to the power of minus 15 meters, but X-rays is 10 to the power of minus 10 meters. It is wrong. X-rays are coherent sources. No, X-rays, how can we say X-rays are coherent? Number of wavelengths will be there in one X-rays. No. Coherent means same frequency, same wavelength should be there. So first option is right answer. Got it, students? Understanding, no? Next, question number 14. What determine the hardness of X-rays obtained from Coolidge tube? Hardness of X-rays, how can we define? By knowing the frequency. Yes. So frequency, we know frequency. We know frequency depends upon potential difference. Clear? Yes. So potential difference between the anode and target element. This determines the hardness of X-rays. Current filament wrong, pressure in the gas wrong, nature of the target wrong. Hardness of X-rays means frequency should be more. When you get higher frequency, frequency should be high means energy should be high. Energy is equal to HF. No, yes. When energy is high, when potential difference is high. No, yes. See, one-to-one chain link it is. Clear? Yes. Option. I hope you are understanding what I am explaining you for you. Is it? Are you understanding, students? Okay, clear? Understanding, no? So what determines the hardness of X-rays obtained from Coolidge tube is the potential difference. Option 4 is right answer. Next, I am going to question number 41. Question number 41, Sinana. All of you. Question number 41. The most penetrating radiations out of following. Beta rays wrong, alpha rays wrong, X-rays is, but more than X-rays, gamma rays will penetrate. So option 4 is right answer. If gamma rays are not there, then we can tick for X-rays because gamma rays are having highest frequency. Frequency is more means penetrating power will be more. Are you understanding? So gamma rays are most penetrating radiations. Remember. Next, 42. On increasing the number of electrons striking the anode or X-ray, number of photons increases means intensity increases. Nana. Remember this point. Okay. Which are the following parameter of resulting X-rays would increase? Intensity. Direct question. Penetrating power. No. Penetrating power depends upon frequency. Means it depends upon potential difference. Frequency wrong. Wavelength also wrong. Only intensity. Direct question. Okay. Next. 43C important pointer. For production of characteristic K beta X-ray, electron transition is from K beta line. K means it should come to n is equal to 1. Means this is wrong, this is wrong. And n is equal to 3 to 1 it should be. Okay. N is equal to 1. N is equal to 2. N is equal to 3. From here to here it is K alpha. From here to here it is called K beta. Means 3 to 1 it should be. It should be 3 to 1. Important, Nana. You can remember this type of short points. Clear? Okay. Next, 44. Question number 44C. Yes. Question number 44, Nana. If X-ray is passed through from strong magnetic field, then X-rays, they never deviate. Means they will undeviate because X-rays are chargeless and massless. Okay. They will deviate maximum wrong. They will deviate minimum wrong. They won't deviate. No deviation will be there. Okay. Next. 45 is important point to be remember. Conceptual question. C. Which of the following wavelength is not possible for an X-ray tube which is operated at 40 kilovolts? Okay. Yes. Which wavelength is not possible? What is the voltage, Nana? 40 kilovolts. Okay. So voltage is given 40 kilovolts. Then what is the energy, Nana? E potential difference means nothing but E into 40 kilovolts is nothing but 40 kilo electron volt. Means energy is nothing but 40,000 electron volt. Okay. Yes. You know lambda is equal to, see, options all are in angstrom. Okay. So 12,400 electron volt upon energy. So 12,400 electron volt upon 40,000 electron volt. Electron volt cancel. Two zeros cancel. 124 by 400 is nothing but 1.24 divided by 4. Correct? Yes. So it can be written as 0.43 12 1. Okay. 0.31. See. Listen, students. Yeah. So the wavelength is 0.31 angstrom should be there. Okay. See, these are X-rays. These are X-rays. So we know X-rays, they will start from one particular minimum wavelength. So that minimum wavelength is 0.31. Less than that is not possible. 0.31 less than which is 0.31 is greater than, 0.52 greater than, 0.5 greater than, 0.25 is less. So this is the right answer. Are you understanding? Which of the following wavelength is not possible? Which is not possible? 0.25 is not possible. Remaining all are possible. These are these 0.5, 0.52, 0.34. These are above this minimum wavelength. So only 0.25 is not possible. Got it? Are you understanding, students? What okay, got it? Next, 45 is over. Next, see question number 46, Nana. If the operating voltage of X-ray tube is 50 kilovolts, then velocity is what? These are X-rays. They are talking about X-rays just. They will travel with speed of light, 3 into 10 to the power of 8 meter per second. If these are not X-rays, if these are anything else, it means any alpha particle, beta particle, electrons are like that, then kinetic energy is equal to EV, that is nothing but E into 50 kilovolts is nothing but 50 kilo electron volt. This is kinetic energy, is nothing but half mv square. From this you will get velocity. But these are X-rays, so that's why they will travel with the speed of light. Option 2, no confusion. Okay. Question number 47C. When X-rays are projected in strong magnetic field, what will happen? No deflection. A direct question. Next, if the voltage of X-ray tube is doubled, then intensity remains constant. With increase in voltage, energy increases. With increase in energy, frequency increases, but intensity is constant. Intensity does not depend upon frequency. That means energy, that means voltage. Okay. So whatever you do for a voltage, intensity remains same. Intensity in the sense number of photons striking the metal target per second. This remains constant. Okay, Anna? Got it now? 48 is remains constant. Next, question number 49. Yes, see question number 49, Anna. If minimum wavelength obtained in X-ray tube is 2.5 into 10 to the power of minus 10 meter, this is the minimum wavelength. Lambda minimum is this much. How much day? 2.5 into 10 to the power of minus 10 meters. This is the minimum wavelength we are getting. Okay. For this minimum wavelength, the minimum operating voltage, how much? What is the voltage? Okay, we know energy is equal to 12,400 upon lambda. That should be in angstrom. Yes. See, 10 to the power of minus 10 is nothing but angstrom, means 2.5 angstrom it is. So energy we can get is equal to 12,400. This is in electron volt upon 2.5. Yes, calculate this. How much you will get? 12,400 divided by 2.5. I am going to do Nana. Yes. 12,400. Yes. 12,400 divided by 2.5 Nana. It is 4,960 electron volt. Okay, na? Yes. And we know this energy we can write E potential difference, and it is equal to 4,960 electron volt. Electron cancel. So potential difference you will get 4,960 volt. It is around 5,000 volt. Is nothing but 5 kilovolts. Yes or no? Yes. Yes. Option 4 is right answer. Got it? Thing is, you need to remember how to do these all problems. Next, question number 50. In X-ray tube, wavelength of X-ray is of the characteristic of target material, not filament current, not tube voltage. It is target material. Okay? Clear? Remember this point. Next, 5,000 volt is applied on electron in X-ray tube. Then minimum wavelength of X-ray is just now I have given lambda is equal to 12,400 divided by lambda voltage in electron volt divided by how much it is 5,000 volt. Okay, 5,000 electron volt. You do this, you will get the answer. Okay. Yes, option is 2.48 into the power of minus 10 meters. Do these calculations, you will get the answer. Okay, 10 to the power of minus 10 indicates in angstrom. It is, yes. Pressure inside the tube. 52 question. Question number 52. See, question number 52. What they have given? Pressure inside the X-ray tube is, it is 10 to the power of minus 10 millimeters of mercury. This is the required condition for a production of X-rays. You need to remember this value. Okay. Yes. Next. 53. See there. Question number 53. 20 kilovolt potential is applied across X-ray tube. Then minimum wavelength. Again, same question in angstrom is nothing but 12,400 divided by 20,000. You will get the answer. Okay. Yes. So you will get the option 1, 0.61. You will get the answer. Do these calculations. You will get the answer. Next, what is the minimum wavelength of X-rays? We know E is equal to Hc by lambda. Then lambda is equal to Hc by E. And Hc by E option is there or not there? Capital E, small e not. So this capital E can be written as Eb. Yes, Hc by Eb is right answer. Energy is in electron volt, no? Yes. Option 2 is right answer. Okay. Question number 55C, direct conceptual question. To increase the hardness of X-rays in QRG tube, what to do, Nana? Frequency should increase. How can we increase the frequency? By increasing the potential difference. Okay? Yes. So, increasing the voltage applied between anode and cathode. Increasing the filament voltage is wrong. We need to increase the voltage between anode and cathode. Nana. Don't get confusion here. Increasing the voltage is there, but it is increasing the filament. It is filament voltage increasing. With increasing the filament voltage, filament current increases. That is the condition here. Wrong it is. Remember. Okay. Next. 55 is over. Next, let us go to 56. Nana. Yes. Question number 56C. For X-ray diffraction, the order of size of the optical is of angstrom, Nana. Direct question. Voltage applied across the X-ray tube is 1000 volt. Direct question, remember. Okay. Which of the following is the wavelength of X-rays? 1 angstrom. Direct questions, Nana. Remember these all. Next. 59C. 59 important question. Easy logical question. The lattice constant for crystal is 3 into 10 to the power of minus 8 centimeter and glancing angle is 30 degrees. For first order diffraction means n is equal to 1. What is the lambda? We know 2d sin theta is equal to n lambda. Okay, 2 into d value given 3 into 10 to the power of minus 8 centimeter into sin theta is given 30 degrees is equal to n value 1 into lambda. So sin 30 is 1 by 2. 1 by 2 to cancel. You will get lambda is equal to 3 into 10 to the power of minus 8 centimeter. Yes. This should be the wavelength used. Yes. Got it? Important question. You need to remember this. Moreover, you will get in chemistry this type of questions, Nana. If you are perfect in chemistry, then physics, atoms and nucleus, both the chapters, problems will be very easy for you. If you are perfect in chemistry, atoms and nucleus chapter problems will be